Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Electromagnetic induction. Consider a magnet and this. So magnetic flux will be there around of it. Now consider a coil which is connected to a voltmeter V. Now if coil and the magnets are at rest, there is no deflection in the voltmeter. This is my coil and this is a magnet and this is magnetic flux. This voltmeter. So when this coil comes nearer to magnet, then there will be some flux linking to this coil. That is known as linkage flux. And this linkage flux will be maximum when it comes to nearer to the magnet, and when this coil goes away from the magnet, then the flux linkage will be minimum. This is maximum. Even the magnet is stationary. If the coil is moving, there will be flux linkage in the coil. That flux linkage is going to cause an EMF in the coil, and that EMF is going to transmit a current through the wires to the voltmeter, which is responsible for the deflection of the voltmeter. Now we'll consider in another way that coil is constant and magnet is moving. So as the magnet comes nearer to the coil, more flux will be linking. As the magnet goes away from the coil, less flux will be linking. That again causes a deflection in the voltmeter. This phenomena is known as electromagnetic induction. This phenomena is mostly used in machines like motors and generators, transformers. Here we have a magnet and a coil. Now we'll consider case 2 that we have two coils. Let it be coil 1, another one is coil 2. And if an alternating current I is flowing through the coil 1, then the change in the current is going to cause change in the flux in coil 1. That flux is going to link with the coil 2, and this flux is going to induce an EMF in coil 2, and current is transferred. So if you connect a voltmeter here, you can able to get the deflection in the voltmeter. Even the current in the coil 1 is changing in magnitude or in direction. In both the cases, EMF is induced in coil 2. If the change in the flux linkage of a coil is due to change in the current in the coil itself, the change in the flux happens here due to the current flowing in this coil itself, then this is known as self inductance. If the change in the flux linkage of a coil is due to change in the current in neighboring coil, that the flux linkage change in coil 2 is due to the current I1, then this is known as mutual inductance. If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.